Alright, let's move on to 11.6 here, solving quadratic equations by factoring. Little new stuff here. Um, we've been working a lot in this chapter on factoring. In fact, the whole focus seems to be on factoring. At this point, we start to work with our factoring and we are going to solve equations. Now remember, equations have an equal sign, and we really haven't seen this yet in this chapter. On these first ones here, we use this process called the zero product property, or sometimes you'll see zero product rule or law. But it's kind of this idea that and I think all of you would know this, that if I told you, hey, there's two things multiplied together to equal 0, that either this thing is going to be 0 or this thing is going to be 0. Now we also could extend that, and if I said, well, there's three things that when I multiply them to 0, this could be 0, this could be 0, or this could be 0. Okay, so that's the idea we're going to use in these first three, and actually through this whole section here. But getting started with this, it says that this parenthesis times this parenthesis is equal to 0. So similarly to this, we can say, well, either this is 0 or this is 0. And so a nice little template to use on this, and I tell students, set both or all pieces equal to 0, and then solve each individual piece. Okay, so if we're solving this piece, we subtract 5, and some of you are much faster than this at solving by now, and we get 6x equals -5. Then we divide by 6, and we get x equals -5/6. Or here we can solve this one. Add 2, and we get x equals 2. So what some students and people have done over the time is start to realize that, hey, there's a shortcut on this. We could change the sign on this and put it over this. Let's try that. Change the sign on 5, -5, put it over 6. That's what we get. Change the sign on this, +2, put it over 1. Well, we start to realize that if there's a 1 up front there, we just change the sign on this and see we get 2. All right, so we just, the shortcut works, but if all else fails, set each piece equal to 0 and solve. So I'm going to set each piece equal to 0 and solve. There's each piece set equal to 0. On the first one, you probably already realize what's going to happen, but I get x equals 0. Or on the second one, we get x equals 2. So there's our solution. Sometimes they'll say write your answer as a solution set, and a solution set would look like this. Okay, solution set. Looking at the last one here, I threw this one in. I don't know why I used x minus 2 so often, but yeah, I did, and it could have been x minus 7. It's just I somehow typed x minus 2 a few too many times. So let's set each piece equal to 0. This one we have to even set equal to 0, but I wanted to do this just to show you what happens. You get 3 pieces set equal to 0. And see the difference between when it's a 4 and a 4x? When we have 4x equals 0, we get this statement, x equals 0. But when we have just a plain old 4, we get this statement here, which just is a bogus statement or a contradiction. So what I do at this point with this one is just cancel it out. That doesn't mean anything. It's a contradiction, okay? Here we can solve these. If you think about the shortcut method, change the sign on 3, put it over the coefficient here of the x term. But if we go through the solving, okay, going through the solving, we get 2x equals negative 3, divide by 2, and we get x equals negative 3/2. All right, and we've done this one before. We find out that x equals 2. All right, so that is our solution, okay, or our solutions. So those are nice problems that are already factored for us. What's going to come up in the next part 2 here is we're going to have them in not factored form, and we're going to have to factor first. So we'll move on and take a look at that next. Thanks.